All right, in chapter 2 of this course, what we're going to be studying is the binary. Actually, we're going to be studying binary decimal, decimal to binary, hexadecimal conversion. We're going to talk about now getting into the architecture of the modern world of digital electronics. So, in a digital world, we know we use a 0 or 1 to represent a Boolean number. So, in binary, if we want to count in binary, and we want to actually know what this is in decimal and hex, there's the procedure to do this, and I'll explain to you, but I'm going to show you how this would look as we lay it out here, and then what we're going to do is do some conversion so you can actually see how this binary value is equal to a decimal as well as a hex number. So, in short, let's start this out. So we know that if I take four binary numbers, 0, 0, 0, 0, and I know that's all zeros, I could say that is a decimal 0. Plain simple, there's all zeros, there's nothing there. We know that a binary has a 0, 1. So if we take and change this placeholder right here to a 1, 0, 0, 0, 1, well, this has to be a 1 right here. So what's going to happen is this number, well, this place right here is going to go back and forth, continue to go back and forth, and I'll explain to you how that actually works in a second here. So if we continue to do this, what we have to look at on here is some addition in binary. So before I actually continue down over here, I'm going to do is, this is addition in binary. So if we look at addition in binary, if we take a 1 plus a 1, well, if we take a 1 plus a 1, that's 1 plus 1, well, it's a 0. Anytime you have 1 and a 1, it's always going to be a 0, and then what we're going to do is move it over to the next placeholder, which is over here. So that becomes, in binary, it's 2. So we're just going to do that is 0, 0, 1, 0. I'm going to make these all zeros so you can see these are not O's, these are zeros. So this becomes a 2. Well, if I keep adding another one here, so if I actually take and do, and if I take a 1, 0, and I add another 1 here because I want to add it, I become a 1 and a 1. Well, there it is, 0, 0, 1, 1. That's 3. So I'm going to continue to do this. I'm going to show you one more of this, and then so I can continue on this. So now we have a 1 and a 1. And you don't need the physics world. You don't need to see physics world. There we go. Sorry about that. So we take a 1 and a 1, and we add another 1 to it. 1 and a 1 is 0. Carry it over to the next placeholder. 1 and a 1 is another 0. And carry it over here. Well, now we have 1, 1, 0, 0. Okay, so now we have 0, 1, 0, 0. That's 4. So I'm going to continue to do this, and I'm going to show you how this works. So 4. So 0, 1, 0, 1 is 5. 0, 1, 1, 0 is 6. 0, 1, 1, 1 is 7. And then if we want to do 8, well, if we do add 1 here, this is going to bring this all the way over here. There's 8, 9, 10, 11, 12, 13, 14, and there's 15. Isn't that interesting? So that's up to 15. You need to know this. So you need to write this stuff down and have this ready for test. I'm going to ask you, what is 1000? And you're going to say, oh, that's an 8. And eventually you'll just be able to see this, and you'll be able to recognize most of these numbers without having an issue. So in a hex system, well, we have binary, we have decimal, now we have hex. Well, hex, what is hex? Well, hexavalue numbers are used mainly in computers and memory, so it's really important. The thing is about hex is that once we go up to 9, there is no 10. It starts with A, B, C, D. So basically it's the same thing, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now when we get to 10, we have A, we have B, we have C, we have D, we have E, and we have F. Plain and simple. So if we look at this part up here, and I write it out, and I'm going to use this as this goes back to some of your elementary. We have the units, we have the tenths, we have the hundreds, sorry, it's supposed to be not hundredth, hundreds, and then thousand. So these are whole numbers. Anything from this point over this way is a decimal. Over this way is a whole number. Is a whole number. Okay. So in binary, we represent that as a base 2. So a lot of cases, this is, you'll see 0, 2. In decimal, we do this as base 10. So we don't usually do this, but it'd be like a 4, and then it'd be a base 10. And then hex is your base 16, and let's say we have 4 again, and that's 16. Now there's another one, we call it octal, and that's a base 8. And if we do use 4 again, that's base 8. So you can see that 4 could be represented by, if it's base 10, that's decimal. If it's hex, it's a base 16. If it's octal, it's base 8. So we can even come up here. If I want to do instead of 4, I could just do 4 base. This would be, keep it that way. Just never mind. It would be this would be. Can't just write it 4 on here. You would have to actually write it out like that. So just keep that in mind. That's why I wrote it out here. I was thinking maybe I could get something simpler, but never mind. Mistake. All right. Any questions on that? Email me. All right. All right. So what we're going to do now is I'm going to look at taking binaries and converting it to decimals. So we're going to say this is binary to decimal conversion. First of all, before we even begin, we have to understand the powers of binary, the powers of 2. Remember, binary is powers of 2. So in this case, when we look at the powers, that's raised 2 to the raised 0, 2 to the raised first, second, third, fourth, and we keep going all the way up. It doesn't matter. What you have over here, down here, is this value of the powers. So this is 2 to the 0 is always 1. Anything raised to a 0 is always 1. Remember that. 2 to the first is 2, 4, 2 to the third is 8, 2 to the fourth is 16. So if we actually take, let's say we want to see if some of our math is correct. Let's say we want to just do an easy one for now. Let's say we want to take, 1, 0, and 1. Let's say we want to know what that binary value is. And, we'll come up with it. So now what we want to do is we want to know the decimal value right here. So we want to know the decimal value. But before we do that, what we have to do is take these two numbers and we have to multiply them. Okay? So when we get the binary value, so now you have to multiply to get this decimal value. So this is still unknown. So what we're going to do is multiply the powers and the binary value, the binary number. Pretty straightforward. So what we're just going to do is I'll put a multiplication right here. So we'll just do that, multiplication right there. So 1 times 1, well, that becomes a 1. 2 times 0 is a 0, and 4 times 1 is a 4. Now what we have to do is add the result. So if we put an add symbol over here, well, that's that. So we have 4 plus 0 plus 1, and the number, so what we're going to do is put that way, throw it down there, and it is 5. 4 plus 0 plus 1 is 5. And it is correct. 101, 101 is 5. Let's do another one. Just real quick, let's do another one here. So if I take and I put in my powers up here, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and then I take my power, 16, 8, 4, 2, 1. This is the value. This is my powers. And we're using 2 here because remember, binary is base 2, so it's 2, 2, 2, 2. Now what we're going to do is let's get a real fancy one here. Let's go with 1, 1, 0, 1, 1. That's our binary number. So now we want to do is convert it. So what we're going to do is we want to find the decimal value. So what we're going to do is multiply power. So what we're going to do is the multiply. Multiply. So I put in my multiply. You notice what I'm doing is I'm going on steps right here, right? So my multiply, 1 times 1 is 1, 2 times 1 is 2, 4 times 1 is 0, 8 times 1 is 8, and 16 times 1 is 16. Whoa, that's nice because it really makes the math really easy, right? So if we look at this, we got 8 plus 2 is 10, that's 26. This is actually the decimal, 27. Well, 8 plus 2 is 10, plus 16 is 26, plus 1 is 27. This is the value of 27. Pretty straightforward. All right, we still have to get binary to decimal. Now we're actually going to take a decimal to binary. So instead of using multiplication, we're going to use division. So we're going to convert 14 decimal to a binary. So what we use is some division here. So we know that we're in binary, so we're going to divide by 2. So if we take 14 divided by 2, we get 7. There is no remainder, so it's going to be a 0. Next, what we're going to do is take the 7, bring it down. 7 divided to 2. Well, it's just going to be a 3. We do have a remainder, and it has a decimal. So if it has a decimal or a remainder, then we have to add a 1 here. Now we take the 3 and bring it down. 3 divided to 2. Well, that's going to give me a decimal. It's going to be a whole number with the decimal, so we're going to have a remainder of 1. And then if we take 1 divided into 2, bring this 1 down. So we're going to bring this 1 back down, and we get 0.5. Well, that's where it has a remainder. That should say a remainder. It's with the remainder. I don't know why I had that with the remainder, and it's 1. Let's do one more. Let's do one more of these. So let's convert 20 decimal to binary. So if we take 20 and we divide it into 2, because why? Because we're doing binary values. Binary values are always 2. That gives me 10, so we have a 0. And I'll explain to you what way this thing should look in a second here. So if we take this 10 and bringing it down, 10 divided into 2 is 5. No remainder, no remainder. So 5 divided into 2 gives me 2.5. So now we have a decimal or a remainder, so that's going to be a 1. So we're going to take the 2 divided into 2. Well, that gives me 1, so that's a 0. And now we're going to take 1 divided into 2. That gives me a decimal, 0.5. So we're going to get a 1. So we have these two numbers, but what does this look like? Which is our most significant bit and which is our least significant bit here? So if we're going to write this out, what we're going to do is if you look at this, just take this whole thing and just flip it that way. So if you're looking at it, it's right over here. So we're going to have 1, 0, 1, 0, 0. So that is going to be our value. This is actually 20. So this is base 2. And if we look at this one and flip it this way, so this whole thing flips, we have 1, 1, 1, 0. Well, that is definitely 14 in decimal. And this is equal to 20 in decimal. Okay. So again, 20 divided into 2 is 10. Bring the 10 down. Just keep going down all the way through this. If you hit a decimal at the end, you're done. So which is our most significant and which is our least significant bit? So LSB, MSB. And if we break this up into 4 bits on this thing, if we break these up into 4 bits, 1, 2, 3, 1, 2, 3, 4, and then we would have another 4 back here. So this would be actually a full byte. We can actually want to make it into a full byte. So we'll talk about that later on.